Hi, so we're still in section, or unit 1, univariate data, and now we're in section 4 on Boxplots, 5-number summaries, and outliers. So what I want to do is I want to consider this data below, and so I've given you this data in ascending order. You can see the lowest number is 70 and the highest number is 100. I want to find the mean and the median of this data. So if you guys could just pause the video, take a second, calculate those means and medians, then we'll move forward with the newer material. All right, so coming back, you should have calculated the mean to be 82.0333. And you should have got the median to be exactly 82. And we got that. There's no exact middle, but whenever you counted, you should have had the middle right here. Let's double check that. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Good. So that is the exact middle, and since there's not an exact middle number, you had to take the average of these two numbers, but the average of 82 and 82 is just 82. So there's my median. So you can see that the mean here is slightly larger than the median, but they're pretty close. So now what we want to do is look at what's called a box plot. So you can see all of this data right here. And if you guys were to plug this data into your Fathom program and you would change the display from a dot plot, which you're familiar with, into a box plot, this is going to show up. And so what on earth is all of this stuff? Well, let's start by looking at this middle line. You've got, sometimes this is called a box and whisker plot, where these are the whiskers. And then you have, your box. So your box and whisker plot. So this middle line right here, let's talk about it first. This is going to be the median. And we saw that the median was 82, and notice that it's exactly at 82. And if I want to draw my line, that median was right here. That was the exact middle. So if that is my median, let's talk about why did they decide to start the box here, which is at 77. Well, this is called quartile 1 or Q1, quartile 1. And what that is the median of the first half of the data. So think about this. If I were to go and start counting just the first half of the data up to that blue line, and I needed to find quartile 1, I would see, let's see, I've got 15, so let's count back. 1, 2, 3, 4, 5, 6, 7. This should be the middle number. And then you can count, you've got 1, 2, 3, 4, 5, 6, 7. So that's the middle. That's quartile 1 right there. So if that's going to be quartile 1, this right here, which is at 84, is quartile 3. And if quartile 1 is the median of the first half of the data, quartile 3 is the median of the second half of the data. And let's see how they're getting that 84. I know that I've got 15 points on each side, so let's count 7. 1, 2, 3, 4, 5, 6, 7. This is that middle number. 1, 2, 3, 4, 5, 6, 7. There's quartile 3. And then the whiskers. Why did they decide how far the whiskers are going to go down? Well, you can see the whisker ends at 70, and that's the minimum number, and the maximum ends at 100. Right here, the max. That's where the second whisker ends, at the max. We're going to ignore those dots for now. We'll talk about what those dots are here in a little bit. So another thing that I think we need to talk about is that these points split up the data perfectly into fourths. So this is the first 25% of the data. Then from quartile 1 to the median, that's the second 25% of the data. Median to quartile 3 is the third 25%. And then quartile 3 on to the maximum is the fourth 25% of the data. And of course, we know 25% times 4 is all the way up to 100%. So why is this whisker right here so much longer than the first one? And why is the box part from quartile 1 to the median so much bigger than the median to quartile 3 if I know they all represent the same number of data points? And that's because the box plot helps us see the spread. It helps us see what the range within each quartile, within each chunk is. So I can see the range from quartile 1, 77, to the median 82 is a larger range, that's a range of 5, than it is from the median of 82 to quartile 3. The range there is only 2. So that's why those boxes are bigger, even though they all represent roughly the same number of points, about 7 points in each, 7, 8 points in each. So now let's talk about interquartile range. Interquartile range is just Q3 minus Q1. Just Q3 minus Q1. It's just saying, what is the range from Q3 to Q1? So for this data point, this is the same box plot. You would have quartile 3 is 84 minus quartile 1 was 77. So therefore my interquartile range is going to be 7. Now, why do we care about that IQR? Well, the IQR is going to help us find outliers. So there could be upper outliers or there could be lower outliers. So first, let's talk about upper outliers. So to find an upper outlier, you're going to take quartile 3 and you're going to add 1.5 times the IQR. And what's that's going to do is going to give you an upper cutoff for outliers. So for my data that I had up here in this box plot, I had quartile 3 was 84. Plus 1.5 times my IQR I found out was 7. So when I multiply the 1.5 times the 7, that's going to give me a 10.5. And I add these together and I get a 94.5. So this is that upper cut, meaning anything in my data that is greater than 94.5, I'm going to consider an outlier. So now when I look back at the data, I can look at it in the box plot up here, I had 2 data points that were bigger than 94.5. I've got 97 and I have 100. So this is what's great about Fathom is whenever you take data and you put it in a box plot, it pulls those outliers for you. It tells you what they are. But you're going to have to be able to prove outliers algebraically, and you're also going to have to prove them whenever you don't have the Fathom program. So here I can say my upper outliers are 97 and 100. So now let's talk about lower outliers. The ones that lie on the far end of the data, to the left. So for the lower outliers, you're going to start with quartile 1. And instead of adding, you're going to subtract 1.5 times the IQR. So what did we see was quartile 1 in my data? I believe it was 77. Yeah, 77. So 77 minus the 1.5 times IQR, which was 7. When I multiply those, I get 10.5. And now when I subtract, I get 66.5. This is going to be my lower cutoff. So anything lower than 66.5 is going to be an outlier, but my minimum of my data was 70. So there's nothing lower than this. There are no lower outliers. So that's how you're going to find outliers using 1.5 times IQR. Just to recap, my upper formula is Q3 plus 1.5 times the IQR. And my formula for my lower cut is Q1 minus 1.5 times the IQR. And those are going to give me the cutoffs to find my outliers. Okay, so now I said, what are the outliers for our data set? Spoiler alert, we actually talked about that in the last slide. We saw that they were this 97 right here and the 100. All right, so now in the next problem set, I'm going to ask you to analyze the data. And so now let's just go ahead and define what does it mean to analyze the data. So first you're going to have to give me the shape. And the shape, what I mean is, what is its skew? Is it skew right, skew left? Is it no skew? Next, I'm going to ask you for the 5-number summary. So 5-number summary is the min, quartile 1, the median, quartile 3, and the max. That's the 5-number summary. Next, I need to add the mean and the standard deviation. The mean gives me the spread. Now, standard deviation we are going to talk about in lesson 1.6. So for right now, don't worry about standard deviation. That'll come later on. But you can give me the mean. And then next, you need to give me the outliers using IQR. You have to show all your algebraic work to prove your outliers whenever I ask you to analyze the data. So when I say analyze the data, these are all of the different things that you've got to show me. And now you should be all set. You should be good to do problem set 1.4.